The concept testing of hypothesis is very old concept, one of the most widely used statistical concept. The thing with testing of hypothesis concept is the concept is very easy. The concept is very simple, and you and me, everybody in this classroom, we tend to use this concept of testing of hypothesis in our general life daily. But there are so many technical jargons. There are so many technical words that are used. Somehow it sounds very difficult. Otherwise, at the root level, if you see, the concept is very easy to understand. So let us understand this concept of testing of hypothesis. As I told you, we do testing of hypothesis every day in our life. For example, there is a function at your home. You have to buy some sweet. 10 kg sweet you have to buy. Okay. You go to a sweet shop. Generally, what happens? 1 or 2 kg they'll give you immediately. If it is 10 kg sweet of one particular variety, let's say laddu or something, do they keep the stock of 10 kg there itself? Does that happen in general? Or do they take the order today and deliver tomorrow? Usually what happens?
Order.
We have to make a prior order and then we have to pay some advance, then they'll give you next day. But what happened one day? Let's say you went to the sweet shop to place an order. I want 10 kg laddu. Tomorrow I want it. But what did the shopkeeper tell you? He told you that this 10 kg laddu is already ready, sir. It's already ready. In front of you, you have 10 kg laddu. If he says like that, are you going to buy directly or are you going to doubt this? Tell me. If 10 kg laddu directly in front of you, are you going to simply say packet I'm going to take, or what are you going to do? Think of general scenario. What do we do generally? Tell me.
Doubt and taste.
We taste it, isn't it? Because 10 kg laddu, if you're taking, you don't really want to take a chance. You take one of them and you taste it. Let us suppose that one laddu you ate tastes really good. The taste was awesome. Then what are you going to do? You're going to accept that the taste is good for all this 10 kg, then you will buy. Imagine that one laddu that you ate is tasting very bad. As soon as you keep it in your mouth, you felt like there is something wrong with it. What will you do? Are you going to assume that this one laddu has some issue? Let me take the rest of the laddus. Are you going to think like that? Are you going to this whole 10 kg laddu? Tell me, what will you do?
Change the shop.
You will not take it, isn't it? You will not change the sample. You will not take the whole population, which means the whole 10 kg laddu. We are taking an opinion on 10 kg by using what? 10 kg laddu, let's say for kg around 25, 250 laddus. You are taking the decision on 250 laddus using one particular sample, isn't it?
Yes.
That is known as testing of hypothesis. Testing of hypothesis. And do you agree we do testing of hypothesis? I gave you one example. We do this testing of hypothesis at multiple places in our general life. Okay. So the 10 kg laddu is known as population. Do you understand the term population in the statistical terminology? What exactly population mean? Population means the complete data, the whole population, isn't it? The whole of the data.
Yes.
Whatever is the exhaustive. In general, you understand this term population, isn't it? Then we start with an assumption. Is there any issue with the voice?
No, sir, it's good.
Okay, fine.
No, sir.
Yeah.
Then we start with an assumption. It's known as hypothesis or null hypothesis. Here, before eating the laddu, what is the assumption that you made? Even if you are eating, what will be the basic assumption that you will make? Maybe, okay, I'm giving you a chance. Maybe the taste is good. That's the basic assumption. Yes or no? That's what you assume.
Yes.
If you feel that the laddu is pretty bad, then you will not even eat it. Yes or no? So you start with a basic assumption. That basic assumption is known as null hypothesis. Hypothesis means assumption. Then let us suppose if you want to test 10 kg laddu, would you really eat all that 10 kg and finally tell that whether it is good or bad? Do you think the shopkeeper will allow that? There is no way. So to test the population, what do we use? We take a
Sample.
sample. In our case, what is that sample? What is the sample size? We took
One laddu.
one laddu,
One.
one piece. Then we tasted it. So the whole testing happened in our mouth. Do you agree with that? Tasted the sample. That is known as test
Yes.
statistic. We use some parameters. We cannot define those parameters right now, but those parameters are in our mouth, isn't it? When I eat a laddu, it has to taste in certain manner. Yes or no? Yeah. Those parameters are in our mouth. Based on that, we either accept or we reject the null hypothesis. Are you with me? After tasting, you either accept or reject the null hypothesis. What do you mean by accepting the null hypothesis? You started with an assumption that the laddus are going to taste good. Then you accept it, you buy the population. After eating it, if the laddu is not tasting good, you reject the null hypothesis. What do you mean by rejecting the null hypothesis? You started by saying that the taste is good, but you reject it. This is known as testing of hypothesis process. In testing of hypothesis process, we take a sample, we do a test on the sample. After doing a test on the sample, what is the final opinion that we take? We take a decision on. After doing a test on the sample, we take a decision on the population. Because in reality, testing the whole population may not be possible. Imagine a milk factory production. In that milk factory, on every milk packet, they write that there is a 2%, butter or something like that. There is something all like they write it, right? 2% or 5% butter, like we did not remove any of the butter or something. Now, is it really possible to do the testing on the whole liters and liters of the milk? Or what are they going to do? If you want to test with this whole milk is acceptable or not, what do? They take in a test tube, isn't it? Yeah, they take a sample. On that sample, the testing will be done. Based on that, the population will be approved, either accepted or rejected. Let us take another example, which is somewhat industry related. Imagine you are a quality head in Mysore Sandal Soap Factory. Mysore Sandal Soap Factory, you are the quality head. Every day, they generate 1 million soaps. 10 lakh soaps they are generating every day. Daily production this much. Okay, because they are actually literally selling in every state in India. Okay, they are also exporting. So daily 1 million soaps they are producing. Assume that the weight of each soap has to be 250 grams. Okay, weight of each soap has to be 250 grams. You are a quality assurance head. What is your job? You have to make sure that it has to be exactly 250 grams. If the soap weight is less than 250 grams, let's say if it is 240 or 245 grams, then the customer will sue us. Do you think the customer has the power to sue a very big company? The company told that 250 grams is the soap weightage, but we give 240 grams for the 10 grams. Do you think the customer can do that? Do you think they
Yes.
have the
Yes,
power?
sir.
Some customers do that, isn't it? They are
Yes.
Yes, sir.
very serious about the quality measures. And is that really a bad sign for the company? It may actually hamper our reputation. Maybe we may pay very less compensation to that customer, but reputation wise, we lose a lot. So we cannot have lesser weight. What happens if the weight of the soap is higher than what it should be? Tell me.
Loss to the company.
That is a loss to the company. It has to be neither higher nor lower. It has to be 250 grams. And this is your job to ensure that. Unfortunately, we do not have a biggest weighing machine where you can put all these 1 million soaps in one go and find out what is the weightage. Okay. So what do we do? Out of 1 million soaps, since you cannot weight all of them on a weighing machine, what you can do to test this, whether it is really 250 grams or not, what would you do? You take a Whenever you have a large population, if you can't really target it, what will you do? You
Take a
take a
random sample.
Random
sample from there. We took a sample of 100 soaps. Then we found their average weight. That average weight is known as test statistics. That is known as test statistic, the average weight, that number. Now, if that average weight is 230 grams, what would you do? Average weight of 100 soaps is 230 grams. What would you do? Are you going to doubt that these 100 soaps are kind of rare? Shall I take a new sample? Or do you think if it is really coming from a population of 250 grams, what should be the average weight of these 100 soaps?
Near 250.
It has to be 250, near to 250. But here it came as 230 grams. Then I would reject the null hypothesis. Tell me, what is the null hypothesis? What is the basic assumption that you started with?
All soaps are 250
All
grams.
soaps are 250 grams. But you tested it and finally found that you are getting very less weightage. Then you'd say you reject the null hypothesis. What if the sample average is 249.5 grams? 0.5 grams change different. That means less than 1 gram difference is there. Are you going to reject this whole 1 million soaps, or would you pass that and you will say that let us go ahead and export it? What would you do?
Yeah, acceptable limit.
Do you think the customer will really sue us for 0.5 grams?
No, sir.
Impossible, isn't it?
There is tolerance also.
Yeah, there is a little bit of tolerance. There must be, like, if it is near to 250, it is fine. But if it is very far higher, far lower, then it's not fine. This is another example of testing of hypothesis. The thing is, testing of hypothesis, concept wise, it's very easy. Only these terms that we see, that's what, like, Generally, when I say assumption, it really sounds very simple. But when I say hypothesis, in fact, the term hypothesis itself, a lot of people struggle to understand what exactly this testing of hypothesis is. The concept is pretty simple. So here, overall data is known as population. Whatever number that you calculate on it is known as parameter. Overall data is known as population. Whatever number that you calculate on population is known as parameter. If you take a sample data, whatever you calculate on it is known as sample statistic. That means population, if you go back to the soaps example, what is the population size? How many soaps? 1 million soaps is the population. What is the parameter? Average weight of all 1 million soaps, 250 grams, is the parameter. What is the sample size that we took in the previous example? What's the sample size? 100 soaps is the sample. What is the sample statistic? Anything that is calculated on the sample is a statistic. Here also we took average of 100 soaps is the sample statistic. What do? We use a sample and the sample statistic. Statistic means a number that is calculated on the sample. Do not confuse this with statistics. Statistics is different. This is sample statistic. So try to use the word sample statistic, a measure that is calculated on the sample. We use sample statistic to infer about the population. We take a decision on the population. This whole process is known as testing of hypothesis. What is testing of hypothesis? What are we testing? A hypothesis on the population parameter. Is the first statement clear? What are we testing? A hypothesis on the population parameter. Is it clear? An assumption on the population parameter. Anything that is calculated on the population is known as parameter. Okay. Hypothesis. What is hypothesis? A verbal statement or a claim or an assumption about a population parameter is called hypothesis. Is the second statement clear to you, all of you? These are all bookish definitions, but by now you should be somewhat comfortable with this. A verbal statement or a claim or an assumption about the population parameter is called statistical hypothesis. How are we testing? How are we testing? Are we really using the complete population and the parameter? How are we testing? Using a sample, and on that we are calculating a measure which is known as sample statistic. Using a sample statistic, we are testing the population parameter. Let us take one more example. This one is the serious example which will lead us to the final complete theory. The CEO of our national bank. Let us imagine a bank like SBI. Whenever you think of SBI bank, tell me what comes to your mind. You feel that a lot of elderly people will be there. The services will be very slow. That's what the general notion a lot of people have, isn't it? A lot of people will complain that when you visit the bank, the work will not be done very quickly. That's what people have, that pre-notion. Now the CEO of the bank, now he is addressing all those issues. He says that he is claiming that our bank have around 3 lakh employees right now. We are there all over India. We have so many ATMs, so many branches. 3 lakh employees are there. We are one of the biggest bank in India, and our employees average age is 35 only. Average age of our employees is 35. We are all very active. You cannot really go with that pre-notion. Our bank is, or our employees are very, very active. That is what he has claimed. Now tell me, what is the null hypothesis? Null hypothesis. Hypothesis means assumption or a statement or a claim. What is the null hypothesis?
Average is 35.
Average age is 35. Now what is the population size? Population size roughly
3 lakhs.
nearly 3 lakh employees are there. So he started with 3 lakh employees. That's the population size. Average age is 35. Now, is it possible to reach out to each and every SBI employee across the whole India and find out their age, find out the average age? Now, it's possible, but does it make the business sense? Is it practically a viable solution, reaching out to each and every employee? Now, that accessing the population is not a practically viable solution. So what do we do instead of reaching out to all the 3 lakh employees to test this? What do? We take a
Random sample.
Sample. It has to be a random sample. Can you very specific? Are you going to take the sample given by that CEO? He's going to tell you that go to this branch, take 10 samples from here. Go to this branch, take 10 samples from here. What will happen? Obviously, he is going to direct us to which locations? The locations where the very young people are there. What are we going to do? Are we going to give any preference when we are selecting a sample? Or are we going to just select randomly? Which one is the right one? Random sample. So how many? Around 500, which is a good enough sample. Random sample of 500 people we are selecting. Usually, statistically, any sample size more than 30 is known as large sample. But for us, when we are doing in business, maybe a sample of 100, or depending on the situation, 500, 1000 also you can take. Here I'm taking a sample of 500 employees from that particular bank. Now you found the average age. If the average age is near to 35, then what would you say? You would accept or reject the null hypothesis?
Accept.
You would accept the null hypothesis. If the average age is, let's say, out of these 500 people, the average age is coming to be 42, what would you do?
Reject the null
Would you
hypothesis.
say that is a very small difference, 35, 42 chalta hai? Is it okay? Are you going to accept the null hypothesis? Are you going to reject the null hypothesis? You will definitely reject the null
Reject.
hypothesis. How about if the average age is 35.5? Are you going to accept or reject?
Accept.
Accept, isn't it? If it is 35, 35.5, it is not very far away. We will say, we are sorry, we were under some wrong notion. Whatever you told is correct. We took a large sample and we tested it. Most of them are around average age of 35.5. So what are we doing? We started with an assumption. Yes or no? We told that, yes, we believe in you. The assumption is that the average age is 35. The overall population is nearly 3 lakh employees are there. From there, we took a sample of 500. On that, we calculated the sample mean. Imagine if the sample mean is 40. The sample mean is also known as sample statistic. Population mean is known as population parameter. Now, there is one of the interview question which is asked, what is the difference between population parameters? What is the difference between parameter and statistic? What should be the answer? Parameter is calculated on population or the full data. Statistic is a measure that is calculated on
Sample.
Sample data.
sample. Okay. These kind of questions only when we listen to this class, only when we practice it twice, then only we will get them. Otherwise, if we do not look at it at all, these kind of questions come as a bouncer, like because we never heard them and they look very, very difficult if you haven't heard parameter, statistic and all that. But the concept is pretty simple. The sample statistic value is around 40. Now, how likely is that if you're taking a sample of 500 from a population where the average is 35, is it very likely that this sample will have an average age of 40? How likely is that? Or not much likely? How likely this situation will happen? It's very, very unlikely, isn't it? If it is 35, somewhere here it will come as 35.5 or 36 or maybe 36.5 or maybe 34.5. But it should not be as high as 40. It's very, very unlikely you reject the null hypothesis. Once again, why are you rejecting it? If your population has an average age of 35, you expect this to be here. The population has an average age of 35. But you took the sample average age, if it is 35.5, then you accept the null hypothesis. If it is 36, then you accept the null hypothesis. If it is 37, maybe you will think about it. But if it is 40, if it is far away from what it should be, if this particular value is 40, if it is far away from what it should be, then what would you do? You reject the null hypothesis. Now, there is only one question that I need to answer you. What is it? How far we should consider? How far is really far? That's the only question that I have to answer you, all of you. Are you with me? Like, what are those limits that I have to consider as acceptable? What are those limits? Beyond them, if I go, I would reject that null hypothesis. Somehow, I have to find out those limits. Now, here is the final point. Once we understand that point, testing is done. Until now, is it absolutely clear to you the story that we have discussed around testing of hypothesis? The only thing that we need to discuss is, okay, we are expecting it to be 35. There are some limits we accept it. Beyond that, we reject it. Can you tell me what are those limits? How do you decide those limits? So here is the process. There is something called sampling distribution concept. What is sampling distribution concept? What is your population size here in your data set? What is your population size in our example? Our population size is around 3 lakh employees.
3 lakhs.
Yes. What is the population parameter value? The average age of all those 3 lakh employees under the null hypothesis, it is claimed to be how much?
35.
35.
Now imagine you took sample 1. How many records are there in sample 1? Randomly out of 3 lakh, I'm selecting
500.
500 in our case. Okay. 500 is the sample that I have collected. I calculated the average age. This is average age value, sample statistic 1. I took sample 2. Another 500. Another 500 means this 500, I kept them back. Again, from 3 lakh, I'm selecting another sample of 500. That is average 2. Again, from 3 lakh, I'm selecting sample 3, average age. Again, from 3 lakh, I'm selecting sample 4, average age 4. Like that, I did this exercise infinitely many times. Whenever you think of infinity, maybe you think of a large number. Maybe I did this repeatedly around 1 million times. 1 million or more than that, I have done that. Maybe 1 crore times, 10 million times. I have repeated this process. What is the process? Tell me. I took a sample of 100 employees, calculated the average. Sample of 500 employees, calculated the average age. Sample of 500 employees, calculated the average age. So how many average age values do you have right now? Average age values. How many of them you will have? Since you have repeated this experiment 1 million times, you will have
1 million.
1 million average age values. Yes or no? Think of it. 1
Yes.
million average age values will be there. Is it possible that one sample is very extreme, that the average age will be very, very less? Is it possible?
Yes.
Since you have repeated it 1 million times, there must be one sample where all the very young people will be selected. There can be a chance that the average age is 20 also. Possibility is there? 20 or 22.
Yes.
Is there any possibility? Because you have repeated it. Is there a chance that there is one sample that you selected, it ended up with everybody is very elderly, the average age is 55 also? Is there any possibility for that?
Yes.
Yes.
But most often, the average age would be around what number? Most often, the average age would be
Around 35.
around 35, isn't it? If it is really coming from a population of 35, isn't it? Yeah. If it is really overall data has the average age of 35, most often the age value will be 35. Sometimes it will be very less, sometimes it will be very high. That is known as sampling distribution. Sampling distribution. What is sampling distribution? It says, actually, this is called a theorem, central limit theorem. What does the central limit theorem say? If you take a large sample, a sample of size greater than 30. In statistic, what is the large sample, small sample sizes? A sample of n size more than 30, that is known as large sample. If you take a large sample whose size is more than 30, taken from a population with the parameter value, mean value mu, then the sample mean that you have will be normally distributed. What do you mean by normal distribution? Around the mean value, there will be a lot of values. If you go far away from the mean value, there will be very, very less number of chances. For example, mean value is 35. There will be a lot of data points around 35 only. There will be some values which are very far away from 35. Maybe 55 will also be here. But there will be very, very less chances. There will be some values which are far less than 35, maybe 20 only. But there will be very, very less number of values. That is what the central limit theorem says. What does the central limit theorem say? If you take a sample, if you keep on taking those samples infinitely many times, the sampling distribution will appear like this. What do you mean by that? If your population mean is 35, what should be the mean of all the sample means? What should be the mean of all the sample means?
Close to 35.
Close to 35. Is it possible that some of the sample means are going very far away from 35? Yes. Some of the
Yes.
sample means are going far lower than 35? Yes, but that chance is very, very less. So in short, you assume some assumption, null hypothesis. You select a random sample. Are we selecting sample specifically with a criteria, or are we selecting randomly? We are making sure that we are selecting a random sample. Then what do? We do a test on that random sample. If the sample is taken from the population, we expect the sample statistic to be within certain limits. That is our selection criterion. Imagine 95% of the times, based on the central limit theorem, we found out that 95% of the times, this number, sampling distribution, should be in between, let's say, 32 and 38. 95% of the times it should stay here. That's what the central limit theorem, or based on this distribution, we found out that 95% of the times it has to be between 32 to 38. The sample mean that you got on this particular test, you got it to be somewhere around 42. Are you going to accept the null hypothesis? Are you going to reject the null hypothesis?
Reject.
You know that according to central limit theorem, you know that if 35 is the population parameter value, 95% of the times, what should be the limits that your sample mean should stay?
32 to 38.
32 to 38. Are you going to accept if it is in between? Let's
Yes.
say if it is 35.5, are you going to accept it?
Yes.
Yes. Even if it is 36, are you going to accept it?
Yes.
Even if it is
Yes.
36.5, fine. 37, fine. 37.5 also fine. 37.9 also you're okay. Though it is
Yes.
less chance, you're still accepting it. But anything beyond 38, let's say if it is 38.2, are you going to accept it?
No.
No.
That is too much, isn't it? You cannot accept that. 95%, like at least that 5% you have to reject. Yes or no? It's a very highly unlikely case. Yes or no? that 5% of the times if it is beyond those limits that you have, then you're going to reject them. You expect the sample statistic to be within certain limits, but it is beyond those limits, and you reject it. So there are 5 steps in testing of hypothesis. You start with one hypothesis, then you take the sample statistic. Based on that, you find out what exactly is the probability that, let's say, 95% of the times you are going to accept it. If it is beyond those, if it is in that last 5% limits, that is when you reject it. Okay. Once again, how do you make the decision? You expect your value to be somewhere here. You expect your value to be somewhere near to 35. Okay. Now there's a concept called p-value. What is p-value? Look at this carefully. What is p-value? Your sample statistic value comes out to be somewhere here. Look at this carefully. This is what you expect your population parameter to be. Your sample statistic value comes out somewhere here. Let's say that is 40. This is a sample statistic value, 40. Now, what is p-value? What is the probability of getting 40 or beyond 40? This whole probability that you see, that is known as p-value. What is p-value? Getting 40 or more than 40. Is it possible to get more than 40 also? Is there a probability?
Yes.
Think about it.
Yes.
So what is the probability that you get 40 or more than 40? But that probability, if it is very, very less, if the p-value, let us suppose if the p-value is only 0.02, that means only 2% probability. Are you going to accept the null hypothesis or reject the null hypothesis? Let me give you a way to decide based on the p-value whether to accept or reject. If the p-value is very less, what does that mean? The p-value is very less. Sample statistic value is far away from whatever is expected or near to whatever is expected. If p-value is very less,
Near.
if the p-value is very less, what means? Like here, your probability is very less. It means it is far away, isn't it? The value, that blue one that you got, that is very much far away from this. Let us suppose another scenario, the value that you got is around 36. P-value is probability of getting 36 and more than 36. Don't you think that p-value will be very high, isn't it? This whole probability of getting 36 more than 36 will be very, very high, isn't it? So if the p-value is very less, what will happen? The probability of the particular value that you got as a result, that is far away from whatever is expected. If it is far away, are you going to accept the null hypothesis? Or are you going to reject the null hypothesis? You expect it to be here, but it is far away. You reject the null hypothesis.
Reject.
So finally, your acceptance or rejection of null hypothesis finally happens based on the p-value. So let us see the analogy of p-value once again. So imagine if the p-value is very less. What do you have to imagine? If p-value is very less, internally, what do you have to imagine? The value that you got on the sample statistic is far away or close to the population parameter. Tell me if the p-value is very less.
Far away.
Sample statistic is far away from whatever is the population parameter it should be. Then you accept or reject the null hypothesis.
Reject.
You reject the null hypothesis. If the p-value is very high, let's say lesser than 5%, less than 0.05, then you reject the null hypothesis. If the p-value is very high, higher than 5%, then the sample statistic that you got is far away or close to whatever is expected. Sample statistic is far away or close to, it is close by. If it is close by, automatically you will
accept
the null hypothesis. That is the testing of hypothesis. Finally, usually people see the p-value based on that acceptance or rejection of the null hypothesis happen. So what is p-value? If the observed statistic happens to be just by chance, p-value tells us what is the probability of that chance. Let's say somebody is telling you that SBI guy who's telling you, yes, we told that 35 is the average age. Then we told the SBI guy that we took a sample and the p-value is very, very less. Let's say the sample average is around 45. That means probability of getting 45, if it is coming from a population of 35, is there a probability? Think about it. 3 lakh employees are there. Their average age is 35. You took 500 employees. Their average age came to be 45. First of all, is there a probability of getting like this? Theoretically, is it possible that from a population, you took a sample average age is 45. Is it possible to get 45 average age?
Yes.
Hypothetically, yes. Is it possible to get more than 45 also?
Yes.
46, 47, 48. There is a chance. So probability of getting 45 or more than 45 is 0.00001. What does this mean? Tell me. It's very, very unlikely. Yes or no? If the SBI CEO comes to you and tells you that, yeah, this happened just by chance, there is a chance that this may happen. He will defend like this. What will be your answer? Yes, it will happen by a chance, but that chance is it very high chance or very low chance?
Low chance.
Very, very low chance. Are you going to accept the null hypothesis or reject it? You will say that we reject it. It may not be coming from 35. We are doubting that this must be somewhere around 42 or 43. That's why it's coming like this, isn't it? That is all you're going to tell. You are going to tell that the chance of happening that is very, very less. Once in US actual court, while some of the lawyers, when they were fighting over a case, testing of hypothesis was used. What happened? It was very old case. What happened in a school around, equal number of male and female have appeared for teacher selection for some particular post. Nearly male were around 550, female were around 450. These many people applied for the job for the teacher post, and they filled 20 positions. Okay. And they told that finally out of 20 position filled, they selected 19 male, only 1 female. So one of these female, like the rest of the female, they have actually went to court. In the court, the lawyer was arguing that, isn't it possible that 550 male have appeared, 450 female have appeared? Isn't it possible that 19 male, 1 female can get selected, right? There is a chance. That's what he told. Now tell me, is there a chance that when these many people apply, almost 50, 19 male, 1 female can get selected? Yes or no? Is there a chance for it? Theoretically, there is a chance. But what is the chance of happening that?
Less likely.
Is it very highly likely or very less likely?
Less likely.
Very less. Like using the testing of hypothesis, they found the p-value. The p-value happens to be 0.00000 around 19 zeros at once. Now that lawyer told that, probability of, yes, there is a chance, but probability, like the lawyer argued saying that, do you think our particular team will win the football matches, football World Cups, next 6 football World Cups consecutively? Is there a chance for it? That's what he asked the judge. The judge will automatically say that winning a World Cup itself is very less chance, isn't it? Winning the next 6 World Cups, there is a chance, but it's almost impossible, isn't it? Consecutively, do you think a team will win 6 World Cups consecutively? Is it possible? Very, very less likely. Now the lawyer told that, you know what, this probability is even less than that. Sometimes the probability is so low, we almost think that it will never happen. So based on the p-value, do we accept the null hypothesis that the selection was done fairly, or do we reject the null hypothesis that there is some bias in the selection? Was there any bias in the selection? Was it done fairly?
Biased.
Definitely, the selection was biased. Then they have done the selection once again. Are you getting a feel of this testing of hypothesis? Everything is around the p-value. You are defining that chance. If you're really getting it from this population, what is the chance of getting this value or higher than that? That is known as p-value. If the p-value is very less, as soon as you look at the p-value, what should be the chain of thoughts that should come to your mind? If the p-value is very less, our sample statistic value is very far away from whatever is the population parameter. If it is very far away, what would you do? You reject the null hypothesis. That is a p-value. Sometimes you may get this question in the interview, explain me the p-value. It's not that easy to explain, but what you can do is using your analogies, you can tell that, in testing of a p-value comes in testing of hypothesis. We take a sample statistic, we calculate the value, probability of getting that particular value or more than that, extreme than that, that is known as p-value. P-value is the answer to the question, what's the probability of observed statistic or more extreme than this when H0 is true? Given H0, probability of current value or extreme than this. Are you getting what I'm trying to say here? Probability of getting this or more extreme than this is known as p-value. Okay. If you remember, in our regression analysis, we have used p-value. Do you remember where have we used p-value in our regression analysis? Why did we use p-value there? In some scenario, we have used p-value there.
Some data. To remove some data.
We have used p-value in variable impact. Do you remember that?
Yeah.
Variable impact, whether a variable is impactful, xi is impactful on y or not. So
Yes.
recollect p-value. Based on the p-value, how did we select? Based on the p-value. If the p-value is less than 0.05, then what did we select? What did we say? There, go to regression, p-value less than 0.05. Variable is impactful or not impactful at that time?
Impactful.
Impactful. We kept such variables. If the p-value is greater than or equal to 0.05, we drop
Drop
them, isn't it? Not impactful. Now the theory behind it goes like this. The test that was done, the null hypothesis, let us suppose you have variable xi, its coefficient is beta I. You want to find out whether this xi is impactful on y or not, okay? So what are you doing here? You started with a null hypothesis denoted by h0. You started with a hypothesis that beta I is equal to 0. If the beta I is equal to 0, what does that mean? Xi has a coefficient of 0. That means what? The variable is not impactful. Are you with me? If a coefficient of a variable is 0, variable is not impactful. That is the null hypothesis. What is the alternative hypothesis? Beta I not equal to 0. It is some positive or negative value. That means it is impactful, either positive or negative. Then we take a test statistic. Finally, we do the testing. Finally, we end up with a p-value. Imagine your p-value is less than 0.05. Tell me what should be the chain of thought that should run in your mind. Now come to the testing of hypothesis. From the testing of hypothesis point of view, p-value less than 0.05. That means the value is far away or close to. Test
Far away.
statistic is far away. If the test statistic is far away, are you going to accept the null hypothesis or reject the null hypothesis?
Reject.
Reject the null hypothesis. Go to the null hypothesis. Tell me what do you mean by rejecting the null hypothesis? Finally, you're stating that the variable is impactful or not impactful. If you reject the null hypothesis, what are you trying to say?
Yeah,
Accept the.
It's impacting.
It is impactful. P-value less than 0.05 variable is impactful. Let's take the another scenario. Take the p-value. P-value greater than or equal to 0.05, somewhere here. P-value is 0.30. That means the value is far away or near to
Near.
so nearby. If it is nearby, what do you end up doing? You accept
Accepting.
the null. Accepting the null hypothesis here in this scenario, it means you are accepting the fact that the variable is
Not
not impactful.
uh,
It is somewhat
redundant.
counterintuitive to the general ones, isn't it? Because here we are starting with the fact that it is not impactful. The whole testing is done around this one, this assumption. All this test statistic, everything is around this. That is how the individual variable impact was decided based on testing of hypothesis back in regression. Okay. While you are doing testing, there will be some sort of errors. Why there will be some sort of errors? Is it possible that you have a population, from there you took a sample, you assumed that it's a random sample? Is it? And based on the sample, you have rejected the null hypothesis. Based on the sample, you rejected the null hypothesis. Is there any possibility that you can go wrong, or
Yes.
always you will be right? There is a chance that you will go wrong because sometimes this sample may not be really the right one, isn't it? There are two types of errors that are possible. One of the error is rejection error. One of the error is acceptance error. For example, the null hypothesis is, am I pregnant or not? So there are some tests that we do for pregnancy. Yes or no? So they took a sample and they are testing. These are the results. So for the first patient, for the same null hypothesis, am I pregnant or not? The test came out and the result was, sorry, you're not pregnant. Definitely that's an error here, isn't it? For the second patient, the testing was done and the result was, yes, congratulations, you are pregnant. That is also wrong, isn't it? Because we are using a sample, we are not really doing it on the population. If you are using a sample from the population, there can be some error. If you are wrongly rejecting the null hypothesis, that is known as type 1 error. If you are wrongly accepting the null hypothesis, that is known as type 2 error. Wrongly rejecting the null hypothesis is correct, but you reject it. Null hypothesis is correct, you rejected, that is known as rejection error, type 1 error. But null hypothesis is wrong, but you accept it, that is known as type 2 error. Sometimes type 1 error is critical, sometimes type 2 error is critical. We want to minimize both of them as much as possible. The reality is it's not true, but you have rejected H0, that is type 1 error. The reality is H0 is false, null hypothesis is false, but you have accepted H0, did not reject H0, that is also error. We want to minimize both the errors, but generally what we tend to do is minimum 5% is what we keep as type 1 error. 5% of the times, even though like beyond 5%, 95% of the times we accept it, even though beyond, if there is a chance also, we tend to reject the values that are falling beyond those limits. Okay. Which error is bad? Generally, this is one of the questions, which error is bad? Is it type 1 error, type 2 error, that wrongly accepting, is that bad? Wrongly rejecting, is that bad? The answer should be both are bad. It depends on the situation. Sometimes you don't want to reject anything quickly. Sometimes you don't want to accept something quickly. So depending on the situation, we have to take the call. This is somewhat like confusion matrix. Do you remember it? Is it like this one
Yes,
is
sir.
bad or this one is? It's very much similar to confusion matrix. It depends on which scenario we are in. Let us try to do an example to get better understanding of it. Until now, I kept on talking. Let us put it to some use. There is one superstore sales data, Roseman store sales data. What I wanted to do is the average number of customers daily. The store manager is claiming that 750 is the average number of customers that I'm getting. Now we want to do testing of hypothesis and find out whether it is really 750 or not. Okay. So let's go to our code file. Send me the code file. Anybody? Testing of hypothesis code file. Here is the code file. Testing of hypothesis. So import the packages. This is the Roseman store sales data. It's a typical superstore sales data. Nothing really complex about it. You have these data points. So we are taking a sample from here. So I'm taking a sample size of 100 from the data set. It's a large data set. From this data set, I'm taking a sample size of 100. What's a large sample, small sample in the general statistical sense? What's the sample size beyond which we call
Greater
it?
than 30 is
30.
large.
Yes. So if your sample size is 100, you should not say that this number is small. You have to say that statistically it's a large sample. Usually random state parameter. Why is it used? Random state parameter. If I'm taking a sample of 100 records in my system, you are taking a sample of 100 records. Is there a guarantee that both of you will get the exactly same records?
Nope.
There's no chance, isn't it? How do you make sure that both of us are getting exactly same records? If you use random state, both of us use the same ID, then we'll get the same record. Random state is used to regenerate the same samples or the same random numbers multiple times. Okay. So that right now, if you see sample sales underscore sample, all of us will have the same sample. Now let us test the first hypothesis. So you write a Z test. This is known as testing of means is known as Z test. And then what are you trying to test here? You're trying to test whether the average number of customers is 750 or not. Tell me. If you're testing 750, you have to write here. In this case, here you have to write 750. Make that change as 750. Tell me what is the result. If the value is null hypothesis H0 is 750 customers, what's the final decision is made on what? Usually you make the final decision based on p value. What's the p value that you got? P value, make it as 750. Tell me the p value. Is it less than 0.05 or more than 0.05? Here, the p value is how much? 9.20 into e power minus 0.5. What does that mean? 9.20 e minus 0.5. What does that mean? It means,
Very far away.
it means whenever you see this number, it means it is 9.20 divided by 1 followed by how many zeros? 1 followed by, since it is 0.5, it will be 1, 2, 3, 4, 5. So p value is 0.00000920. If p value is this much less, p value is very less. What does that mean? It means
Far off.
the test statistic is far away from population parameter. Are you going to accept or reject the null hypothesis? The test
Reject.
statistic is far away, then you reject the null hypothesis. Let us suppose we went back to that manager. Yeah, you told that 750 is the average number of customers that you are getting every day. We reject the null hypothesis. He says, sorry, not 750, it is 700. Sorry, I told you by mistake. Are you going to believe in him or are you going to test again?
Test again.
Test again. Go ahead, test again. Tell me what is the p value this time with null hypothesis changed to 700. What's the p value?
0.0009.
P value is 0.00009. P value is 0.009. What's the general limit that we have for the p-value? What's the p-value limit for you?
0.05.
0.05. Are you going to accept or reject? P-value is less than 0.05. It means test statistic. That means p-value is very less, isn't it? If p-value is very less, what does that mean? It indicates that
Reject.
no. What is the full story?
Okay.
P-value very less. That means the test statistic is
Uh,
far away. Yes or no?
yes.
Test statistic is far away. If it is far away, then you reject. So what are we rejecting? We are rejecting this also. We again went back to the manager. We told that, yeah, you told 700. That is also not right. Then he told that I'm really sorry. It's actually 650. That's what he told. Are you going to believe in that? Or are you going to test it?
Test again.
Test again. So test it with 650. Tell me what's the p-value?
0.19.
P-value is 0.19, which is greater than
0.05.
0.05, which means your test statistic is near to the population parameter. If your test statistic is near to population parameter, you accept the null
Null
hypothesis.
hypothesis.
Like that, based on the p-value, you take the decision. You can also try this example. This one is on the customers. This one is on the average sales. There are other tests like Z test, T test, F test, chi-square test for independence. Testing multiple means also. Everything will boil down to a test statistic. Finally, this test statistic, we will end up in what? Finally, what do we do to take the decision? Finally, to take the decision, we look at the p-value, isn't it? We look at the p-value. If the p-value is less than 0.05, tell me once again. I know I'm repeating it multiple times, but this is important one. P-value less than 0.05, it means test
It's close.
statistic is
Yes. Near to the population.
p-value less than 0.05. That is
Oh,
p-value
sorry.
is very less.
It's far away from
It
population.
is far away. That's why you reject the null hypothesis. Whatever is the null hypothesis. P-value is greater than 0.05. P-value is high. That means it is nearby. You accept the null hypothesis. Okay. Like that, you have test for two means. You have test for multiple means, which is known as F test, etc. All these tests are somewhat similar. But there is one test which I have seen. It has been discussed in the interviews multiple times. I'll explain you that test in depth, which is known as chi-square test of independence. This chi-square test is done by calculating the chi-square value. This test is done to test whether two variables are independent or not. Especially if a variable, this is x variable, let us suppose this is y variable, whether x is independent of y or whether x is dependent on, or whether y is dependent on x, that can be done by using this chi-square test of independence, whether a variable is impactful or not. Exam result is the target variable. Imagine the target variable is exam result, which takes values pass or fail. One of the x variable is gender. If somebody is claiming that gender is an impactful variable or gender is not impactful, how do you prove it? Whether gender is independent or whether exam result is independent of gender or whether exam result really depends on gender. How do you decide it? Let us see an example. Look at this, all of you. There are 500 male, 500 female appeared for the exam. Okay. Out of that means total 1000 people, 1000 students appear for the exam. Out of 1000 students, 600 have passed the exam, 400 have failed in the exam. What percent have passed? Pass percentage is how many people have passed? 60%. How many people have failed? How many students have failed? 40%. Tell me one thing. Imagine gender and exam result have nothing to do with each other. Imagine both of them are independent. Both of them are independent. They have no relation to each other at all. If that is the scenario, if that is the case, okay, out of 500 male, how many should be passing?
300.
300 male should pass, because how did you get exactly 300? You're thinking pass number of people who
60%.
passed are 60%. That means it should be 300. How many male should fail? 200.
200.
How many female should pass exactly?
300.
300.
300. How many female should fail? 200.
200.
Is it fair to say this is the expected table? Expected table when gender and exam result are independent. Yes or no?
Yeah.
Yes.
Yes.
If they are totally independent, exam result has nothing to do with gender. This is the expected table. Imagine these are the observed values. This is your expected value. These are your expected values. All of you, are you absolutely clear on these expected values? How are we getting them? If 60%
Yes.
are passing, 40% are failing, Even in male also same thing should happen. Female also same thing should happen. Then we would say our male or female doesn't matter. But this is what in reality, these are the observed values that you got. Out of male, 500 people, 100 only passed, 400 failed. Out of female, 500 out of 500 passed, 0 failed. Tell me, gender and exam result, pass or fail in an exam, does it really depend on the gender, or do you think gender has no role to play? What do you think?
Here it
Impactful.
is. There is a role.
Gender is an impactful variable. Do you agree
Yes.
with that? If
Yes.
a particular student is female, there is a very high chance that
She will pass.
she will pass. If a particular student is male, there is a very high chance that there is a fail. So what I'm saying is, if they are independent, the value should be somewhat like this. Imagine these are not the numbers. Imagine here it is around 298 of male have passed. Okay, around 202 male have failed. 202, 292 female have, or like say here it is 302. This is 198. If this is the number, what do you think? They are independent or dependent? Passing or failing? Does it
Independent.
depend on the gender or independent?
Independent.
Why are you
Independent.
saying that these numbers are very close to these, isn't it? These
Yes.
numbers are very close to this. So this is the table. This is the table. When they are independent, the numbers look like this. If the actual values are very far away from them, is it fair to say there is a dependency? Look at this, all of you. Exam result has a
Yes.
dependency on gender here. When do you do that? When this table values are very far away from the table of independence. That is why there is a value that is calculated, which is known as chi-square, which is observed values minus expected values. Observed values minus expected values. That means if that number is very high, that means observed are far away from expected. That means this chi-square value is high. That means there is dependency. Do you agree with that? Chi-square value high means observed and expected are far away from each other. There is a dependency. Chi-square value low. When chi-square value will be 0, observed and expected are almost same. That means here 300, 200, 300, 200. Observed, expected are same. That means this is independence table. This is also independence table. Both of them are independent. Chi-square test is used for testing of independence. That is done by using the chi-square value. Observed value minus expected value whole square divided by the expected value. That whole number is known as chi-square. Based on that, the p-value is calculated. Based on that, whether two variables are independent or not, that is decided. So, what is the test for independence? Chi-square. Are you with me? One of the
Chi-square.
interview question that is asked is, how do you test using testing of hypothesis? How do you test the independence of two variables? Which test is that? Independence of two variables is tested using
Chi-square.
chi-square test. This is whole theory. You generally don't need to calculate all this in any of the testing. Naturally, final decision. How will you take the final decision based on the p-value? Chi-square, null hypothesis is independent. Alternative hypothesis is dependent. Independent, if both of them are independent, then this is the table that you expect. Okay. If both of them are not independent, if they are dependent on each other, the numbers will be far away from this table. That's how chi-square test is. But usually chi-square explanation, people are not asking. What are they asking? They are asking about a simple question, whether you are aware of chi-square test or not. Basically, the same question is rephrased in different manner. You want to test the independence of two variables. How do you do that? What should be your answer? You have to answer saying, we will use chi-square test of independence for that. We look at the p-value. Finally, we decide whether two variables are independent or dependent on each other. That is a story of testing of hypothesis. Usually, this testing of hypothesis, conceptually, it's not very difficult, but the terminology that is used in the testing of hypothesis, what is the hypothesis, what is the p-value, once we get some good clarity on that, then things will become easy.